Today we are going to discuss some theorems on real analysis. Okay, so theorem or example. Theorem. So prove that okay, prove that if image of x intersection y means image of two set, image of union of two, sorry, image of intersection of two set, image of intersection of two set is subset of image of intersection of images. This is so here theorem says that image of, this is image of intersection of two set, image of intersection of two set is the intersection of is the subset of intersection of images, or this question is also asked in the form of prove that the relation does not hold, and this relation is f of x intersection y is equal to f of x intersection f of y. Okay, so question is also asked in exam in the form of this type. Okay, prove that the relation does not hold means this equality does not hold. Okay, so only f of x intersection y is subset of f of x intersection f of y. Okay, so proof of this theorem. Okay, how to proving this theorem? Here one part is similar way of previous theorem. Choose any one elements from f of x intersection y, and to show that this those element is belongs to in f of x intersection f of y means image of f of x intersection image of y. Okay, image of x intersection image of y. So first to show that f of x intersection y is subset of f of x intersection f of y. Okay, and here first to where f from a to b. Okay, f from a to b, and x is subset of a and y is also subset of a. Okay, this is very important function from a to b, and a and x and a is subset of a. Okay, then their images belongs to in b. Okay, so how to proving this theorem? Let to show f of x intersection y is subset of f of x intersection f of y. Okay, where let f from a to b be a function, and x is subset of a, y is also subset of a. Okay, to show f of their image means x intersection y, and in image of these two sets is subset of f of x intersection f of y. Okay, now how to prove here? Let b belongs to, let choose any one element from f of x intersection y. Okay, choose any one elements from f of x intersection y. Suppose that let b belongs to f of x intersection y, and to show that this b belongs to in f of x intersection f of y. Okay, so b belongs to image of x intersection y. Okay, here any function is defined here. Suppose that here, suppose f from here x, okay, x and y, this is belongs to in a, f from a to b. Function is a here x and y is a subset of a. Okay, therefore their element is also belongs to in a, then their image is also belongs to in b, means the b contains element of the form of f of x. Okay, f of x means image of x. Okay, so using this here f of x intersection y, f of x intersection y means image set of x intersection y. Okay, here x is subset of a, y is subset of a, then x intersection y is also subset of a, but their image is belongs to in b. So choosing one elements from this set, suppose b belongs to f of x intersection y. Okay, suppose b belongs to f of x intersection y, then means b is belongs to in image set of f of x intersection y, which implies that there exists at least one element, there exists at least one element a belongs to x intersection y. Okay, there exists at least one element a belongs to x intersection y, such that their images belongs to in this set, means equal to b. Okay, therefore f of a is equal to b. Okay, means at least one of the element is exist in x intersection y, their image is also belongs to in f of x intersection y. Okay, so using this criteria, so here choosing one elements from f of x intersection y, here at least, okay, here at least one element is exist in f of a, a means domain, domain means x intersection y. Okay, here to choosing elements from x intersection y, there exists at least one element a belongs to x intersection y, such that f of a equal to b. Okay, f of a equal to b means at least one of the element is exist such that b is a image of any element of x intersection y. Okay, so b belongs to f of x intersection y, there exists at least one of the element is exist in x intersection y, such that f of a equal to b, which implies that a belongs to x intersection y, which implies that a belongs to x and a belongs to y. Okay, a belongs to x intersection y, intersection means this element is common in x and y, which implies that a is also belongs to x and a is also belongs to in y, then their images, okay, a belongs to x, therefore their image is also belongs to in f of x, and here also f of a is also belongs to in their image f of y. Okay, a is belongs to f of y, which implies that their image also belongs to in image set of y, therefore f of a belongs to f of x, and here also f of a belongs to f of y, which implies that f of a belongs to their intersection, f of a also belongs to in their intersection. Okay, means f of a belongs to f of x intersection y. Okay, therefore f of a belongs to f of x intersection y, therefore f of a belongs to f of x intersection f of y, but f of a is equal to b, and this element is element of f of x intersection y, which implies that b belongs to f of x intersection f of y. Therefore V is the element of f of x intersection y, and which is belongs to in f of x intersection f of y. Therefore, f of x intersection y is subset of f of x intersection f of y. Okay, so this is first part of this theorem. Then second part how to proving means conversely part is does not hold. For does not hold, give counter example. Counter example is here to give the counter example for converse part. Here converse part is does not hold. Okay, because converse part is does not hold. Why? Suppose that means f of x intersection f of y is does not a subset of f of x intersection y. Okay, f of x intersection f of y is does not is not a subset of f of x intersection y. Means intersection of images of two set is not a subset of image of intersection. Okay, so there for this counter example is suppose that a and B is a set of real number, means function from set of R to set of real number to real number. Okay, where and choose any two subset x is equal to and y is equal to. Okay, x and y, these two subset of this set of real number, such that x is all positive real number, and y is all negative real number. Okay, and their intersection is empty set, because x contains all positive real number and y contains all negative real number. Therefore their intersection is empty. Okay, x intersection is equal to 5. Okay, and here function defined as the form of f of x is equal to x square. Okay, f of x is equal to x square, where x belongs to set of real number, means for all real number f of x is equal to x square, means their images belongs to in R, such that x is has a image is x square. Okay, means 1 belongs to set of real number, then their image f of 1 has value 1, 2 belongs to set of real number, then 2 has image is 4, and minus 2 is also belongs to set of real number, then minus 4 has also value is minus 2 has also value is 4. In similar way f of their images f of x intersection y is equal to 5, which implies that their image is also non-empty. Okay, empty set, image of empty set is empty set. Therefore f of x intersection y is equal to f of x intersection y is equal to 5. This is one part. So second part is x is set of real number of set of all positive real number, then f of x, when function f is applied on that x set, means positive real number, then their value is something all positive real number. Okay, their value is square of each element, means 1 4 9, also 1 by 2 has square 1 by 4. Similar way, in this each element has a positive value. Okay, each element has a positive value, means image of each element in x is a positive. And similarly f of y is a set of all negative real number, and square of negative real number is also positive real number. Okay, the f of y is also positive real number, which implies that f of x and f of y, which implies that f of x intersection f of y means some which is number of elements is are common in that set. Image set is a contains number of all elements, because this is positive real number, this is positive number. Minus 1 belongs to y, then their image is 1. Also similarly 1 belongs to in x, then their image also is equal to 1, means 1 is common in their images, means 1 belongs to f of x intersection f of y. Similarly similarly infinity elements are exist which is are belongs to in their image intersection of their images. Okay, means in f of x intersection f of y is a non-empty. Therefore here f of x intersection y is empty set and f of x intersection f of y is non-empty set, which imply that f of x intersection f of y is not subset of f of x intersection y. Okay, so conversely or converse part is not hold, converse part is does not hold, that is f of x intersection does not or need not be hold. Okay, that is f of x intersection f of y is does not subset of f of x intersection y. For example, give here counter example. If f from a to b if a to b where a is equal to b is equal to set of real number defined by function defined as f of x is equal to x square, where x belongs to set of real number. Set of real number is set is from minus infinity to open interval plus infinity. Okay, so where let then choose their subset. Let x is equal to set of all positive real number, set of all positive real number, and y is equal to set of all negative real number, all negative real number. Okay, then therefore then x intersection y, intersection of these two set is empty set, then their image, which implies that image of intersection of two set is also empty set. Okay, this is one. Okay, but intersection of but f of x intersection f of y, here image of x intersection image of y is non-empty. Why this is non-empty? Because infinity number of elements are common in that set, because image of x is also set of positive real number and image of y is also set of positive real number, and therefore means since image set of f of x is from or open interval 0 to infinity, and f of y their image is also 0 to infinity. Okay, means set of all positive real number. Therefore f of x intersection f of y contains infinity number of elements, so f of x intersection f of y is non-empty, and therefore this is equation number 2. Okay, therefore f of x intersection f of y intersection f of y is a not subset of subset of f of x intersection y. Okay, this is proof of theorem, that is equality does not hold, f of x intersection y is not equal to f of x intersection f of y. Okay, this is proof of our theorem. Okay, then next definition, composition of function. Composition of function. Okay, so definition of this theorem, let f from a to b, let here function defined from a to b, and next function is defined from g from b to c. Okay, then we define the function then we define the function G composition F. This is symbol of composition. This is small circle, very small circle, G composition F. This is a notation of composition function. Okay, G composition F by and they are defined as G composition of X. Okay, G composition of X is equal to G of F of X. G of F of X for all X belongs to A, means G composition function F is from A to B, then B to C, means G composition F from A to C. Okay, A to C by G composition of X equal to G of F of X. Here how to define here? Firstly we apply function F, and F is function from A to B. Okay, means elements of B is a image of F, means F of X. B contains the image of X for all X belongs to A. Okay, then apply G on that element, means set of B. B contains element of image of F, means F of X. Okay, then apply G on that element and their image belongs to C, means composition of F of X is equal to G of F of X. Okay, so this is definition of theorem. Okay, then the function G composition F. The function G composition is F is called composition of F with G. It's called composition of F with G. Okay, composition of F with G. Therefore, G composition F from A to C is G composition F of X, because A is contain elements of X, and then G composition F is function apply on that element. Their value is G of F of X for all X belongs to A. This is the definition of G composition of F. Okay. So, for example, if F of X is equal to 1 plus sin X, where X belongs to minus infinity is less than X less than infinity, means X belongs to set of real number. Okay, and G of X is equal to suppose that X square. This also belongs to 0 less equal X less than infinity. Okay, means this is set of all positive real number. Okay, then to find G composition of F and F composition of G. Okay, G composition of F and F composition of G. Okay, first G composition of F of X. G composition of F of X is equal to, what is definition of G composition of F of X? Is G of F of X, and value of F of X is 1 plus sin X. Okay, value of F of X is 1 plus sin X. Then G apply on that this one element. G is apply on that this element. Okay, 1 plus sin X. G of X. This is say that X 1 plus sin X is equal to, suppose that X. Then G of X is equal to X square, means their whole square. 1 plus sin X and their square. Okay, G is applied on that element. This is suppose that this is one is whole element. One of the 1 plus sin X is equal to, suppose that X. Then G of X is equal to X square, means this X is equal to 1 plus sin X their square. Okay, 1 plus sin square, and their value is suppose that 1 plus 2 sin X plus sin square X. This is value of G composition of F. Okay, and reverse way, F composition of G is equal to value is F of G of X. Okay, then f of g of x value is x square, and x square is equal to, their value is function is applied on that this element, then 1 plus sin x, x is equal to x square here, so their value is 1 plus sin x square is equal to 1 plus sin square x. Okay, this is the value of g composition of f and f composition of g. How to find g composition of f and f composition of g? So in this way find composition function of values. Okay, so next is real valued function. What is meant by real valued function? Real valued function is a function from any set to set of real number. Okay, real valued function. Next definition, real valued function. Real valued function means a function from any set to set of real number. It's called real valued function. Definition: if f from a is any set to set of real number, means codomain of real valued function is fixed, so which is real set of real number, we call f is a real valued function. Okay, so this is one definition. Then next definition, addition of real valued function, subtraction. Okay, if f from a to r, if f from set of any set to real number r, and g from any set to real number r, we define addition of two real valued function is again real valued function. We define f plus g as the function, whose values at x belongs to a. We define function f plus g and their values at x belongs to a is equal to f of x plus g of x. Means when function f plus g is applied on that element, apply on that set of elements in a. Okay, f of x, that is f plus g of x is equal to f of x plus g of x. Okay, their meaning is f plus g of x is equal to f of x plus g of x. Okay, means sum of two function of x is equal to functions of sum. Okay, so here f from a to r is defined and g from a to r, then addition of two real valued function is defined as the form of f of x plus g of x. Okay, f plus g is a function from a to r. Okay, f plus g is a function from a to r. In this inset notation which can be written in the form of inset notation. This is very important. F plus g is equal to x, means function f plus g is applied on that this x, then their value is f of x into f of x plus g of x, where for all x belongs to a, and this is a set of f plus g. Okay, that is f plus g is real valued function. Means addition of two real valued function is real valued function. So it is clear that in this definition. Okay, function f of x, there means this means that f plus g is function apply on that this x, then their value is f of x plus g of x. This is the mean of this set. Okay, so similarly we define f minus g multiplication of two real valued function and division of two real valued function as f minus g of x is equal to f minus g of x is equal to f of x minus g of x for all x belongs to a. Here f plus g is function from set of a to set of real number. Okay, so in this way f minus g is function from a to set of real number r. Then their value is f of x minus g of x for all x belongs to codomain a. Then multiplication of two function is f of x into g of x for all x belongs to a. Similarly, and for lastly division of two real valued function. If here only one condition, if g of x is not equal to 0, means value of image of g, okay, image of g is not equal to 0 for all x belongs to a, means each element of a. Then we define f by g of x is equal to f of x divided by g of x for all x belongs to a, and here condition is g of x is not equal to 0. Okay, condition is g of x is not equal to 0. This is the definition of addition, subtraction, multiplication and division of two real valued function. Okay, then next definition is scalar function. Okay, or scalar valued function. Okay, if f from a to r and c is any constant real number. Okay, c is any real number that is c belongs to set of real number, means any constant number. The function cf, c is any constant, this is function. Okay, this is called scalar valued function. Okay, is defined by cf of x is equal to c into f of x for all x belongs to a. Okay, this is definition of scalar valued function. Scalar real valued function of scalar valued function. Okay, so this is definition of scalar valued function, means when cf is applied on that this element, then their value is c constant as it is into image of x, means f of x. Okay, c into f of x. So this is called scalar real valued function. Okay.